All right. I'm going to try to explain this easily and simply. So the first thing you need to do, you need to look at the top of the laser. Top of the laser, it's got one port in the center for the vertical laser beam, and then it's got two sets of marks. There's an X and a Y. You need to know the directions of both of these sets, because you need to align one of these sets with the axis of the slope that you're working with. So the slope that we're working with goes down along this axis, right? Now, you can be anywhere in this zone as long as one of these sets of marks is parallel to this axis. You can be over here, you can be over here, you can be over here, wherever you want to be. You just have to be aligned, all right? So, just for example, we're going to be at the top of the slope. We'll be at the top of the slope right up here in the corner. You'll have one set of marks that's lined up, and you'll have one set of marks that's not. You'll have to know which is which, because you have to select which axis you're actually going to be adjusting for the slope. So, the next thing you need to do is along this axis, you will have to set the correct height. So you'll get it set up properly. So the next thing you'll do, once you have the story pole set and your laser set and you know which axis you're working with, you have to find a point 10 feet down the adjustment axis. So you'll have to move down that axis, the axis you're adjusting, 10 feet. And you'll have to find that point. And this does matter. It's from the center of the laser, 10 feet. You want to be as close to that as you can get. We're not building rockets here. It needs to be reasonable precision. All right? So what you're doing here is we have our laser up on its fancy tripod, right? And we have our slope going down. We have a down slope. So we find a point 10 feet away from the center of our laser. So nice center line and out 10 feet. We're going to take the story pole with the setting of the proper height from before, and we're going to come out to that 10-foot mark with the story pole, and we're going to we have to get two numbers. Well, we have to get one number. We need whatever slope we have translated into slope per foot. And then that needs to be multiplied by 10, because we have 10 feet. So whatever that number gets you, you need to move the laser in the direction of the slope. So if the slope is going down relative to where the laser is, you have to move the sensor down that distance. So if our slope per foot is 0.6 inches per foot, we have to go down 6 inches. So we move our sensor down 6 inches, because what we're doing here is we're taking the flat plane that is the laser. When you turn it on, laser will always self-level, and it will be a flat plane. This is a level plane. Now, we just set this to the proper height along the other axis. So that axis isn't moving. Only this axis is going to move. So we've moved our sensor down this number, slope per foot times 10. The sensor goes down that distance. Now we take our remote, we select the axis we want to move, and we begin to adjust it down. And we adjust the laser beam down. So we're not, this distance right here doesn't matter currently. That is moot. What we're doing is we're moving this distance. This distance matters. So you're going to adjust the laser until the sensor reads correctly after adjusting it down our slope per foot number. And that's going to move our laser. It's going to move the beam. That's what we're doing here. Once the beam is moved to the correct position, the sensor returns to its initial point, where you set it before on the y-axis. So it goes back up the slope per foot number. It does not get set to this height. It goes back up the slope per foot number. Because what that will do is that will take that will take the correct distance that we have over here of ground to laser beam, and it will allow it to be translated anywhere along this beam. And this beam covers the entire zone that we're working on. So you'll be able to come out anywhere in this zone and have that initial reading read properly on the story pole anywhere you are. And this is important because as you come back up with lifts, you can adjust the story pole up. You can just adjust the bottom of the story pole up the amount of the lift. So if you want to go up 4 inches in a lift, you just adjust your story pole as you would normally, and you will get the +4 anywhere in the zone. We'll see if we have any questions. So we're going to do a little addition here. If you want to use a machine along with our laser sensor, you have to make sure that whatever bucket you use, if it's the excavator, if it's a skid steer or a loader, the bucket and arm have to always be in the same position for reading. So if you're using the excavator, my terrible drawing, and you have the bucket and you have the sensor, the bucket must always be in the same position, and the arm, when you take your readings. You can dig as much as you want anyway, but when you read the sensor, the bucket and the arm have to be in the same position so that this distance right here is always the same. And the same goes for a loader. If my terrible loader drawing, how am I going to do this? So we'll have just a really terrible arm on this loader. The bucket always has to be in the same position. No matter which machine it is, the bucket always has to be in the same position, bucket and arm. Because you can put that laser sensor back here, but if the arm goes up, your reading changes. And if the arm isn't all the way down, it'll be really hard to get that same reading ever. The excavator's much easier and a little bit harder at the same time. The arm, it's really easy to see that the bucket is in the proper position, but it's very difficult to make the sensor, the arm and the sensor, always be the same amount of level. It's easy for this to be 10 or 15 degrees in either direction and you not be able to tell from the cab of the excavator. That's why sensors for machine control will have a plumb sensor, so they'll tell you when your arm is plumb. And that's got to be the worst skid steer I've ever drawn. Might be the only skid steer I've ever drawn. I don't know.